Dear listeners, let me introduce you our contribution called Pyrolysis of wood biomass to obtain biochar and its subsequent application. Biochar is a waste product that is created during low temperature carbonization of wood biomass. It has a compact hydrophobic core surrounded by a shell with hydrophilic and other active properties. It can be used in many environmental applications, for example as a sorbent. You can change its characteristics by physical or chemical modification. In the first part of our contribution, we determine its parameters, such as the surface area, type of pores, thermal stability, and functional groups on the surface of biochar and its modifications. The morphology of biochar is shown on the picture on the second slide. Active surface area of initial biochar is 571.6 plus minus 0.2 meters squared per gram. Predominant character of biochar is micropores. The area of micropores is 325.7 meters squared per gram. We modified biochar by joint oxidation with various oxidizing agents in the environment of sulfuric acid. We also changed weight ratios of biochar and graphite, and a part of prepared products were also reduced. You can see a list of prepared products on the first slide that were further tested as sorbents. Detailed reaction conditions are described in the full text of our contribution. On the first slide, you can see the chosen examples of the results of the test of thermogravimetric analysis. For the illustration, there were chosen samples of initial biochar, reduced graphene oxide with biochar in weight ratio 1:1, and the last was graphene oxide with biochar in the presence of acid anhydride. In case of biochar, there was exothermic decomposition up to 550 degrees of Celsius at the minimum level. At higher temperature, up to 700 degrees of Celsius, the weight loss was 77%, with the exothermic maximum at 673 degrees of Celsius. The second chosen product, reduced graphene oxide in 1:1 ratio, was thermally neutral up to 380 degrees of Celsius. The whole exothermic effect occurred in the temperature range between 380 to 680 degrees of Celsius. In the last chosen spectrum, there was no weight loss up to temperature 400 degrees of Celsius. Reaction was thermally neutral. The thermoanalysis occurred in two stages, in the temperature ranges between 400 to 600 degrees of Celsius and between 660 to 880, with a maximum at 826 degrees of Celsius. In order to verify the absorption-ability of biochar and its modifications, we used samples as wastewater from petrochemical industry. The results were compared with efficiency of active coal in terms of chemical oxygen demand and non-extrudable compounds. Biochar was better sorbent, and more information about experiments are described in the doctoral thesis. More tests of biochar and its modified products were performed in the National Institute for Nuclear, Chemical and Biological Protection, specifically determination of breakthrough times for sulfur mustard. And because of lack of time given for the presentation, you will find more information and details in a full version of our article. Thank you for your attention.